In this video, I'm going to review the answer key for the last quiz, quiz 4, and quiz 4 was related to the operation amplifier topic. If I were you, I will just summarize the all formula I used to solve my homework. So as you see here in the sheet, I have the formula for inverting amplifier, non-inverting amplifier, voltage follower, summing amplifier, differential amplifier, and the non-zero level detection, which is the comparator. And even I summarize here, some kind of the answer key of some problem in the homework. So let's go ahead and start solving the quiz. That was the first question, and the first question is very easy. And when I look at this configuration, I can tell it's an inverting amplifier. So if you go to the formula sheet I just put in the first page of this video, you can find the formula. Even you can find it in your slides of the lecture. So the output voltage for inverting amplifier will be the voltage output will be equal to minus this resistance R2 divided by R1. So R2 divided by R1 times the voltage input. The output here, the question that they want the output to equal to -3. So I say by -3 voltage is equal minus R2 is not given. So I say R2 divided by R1, which is equal 10, multiplied by the input voltage, which is equal to 0.5. Accordingly, I can just say R2 over 10 will be equal 3, okay, divided by 0.5, which is equal to 6. So R2 will be equal to 6 times 10 will be 60 kilo ohm. And the answer, I just put it here, 60. And will be the first question. Simple. Okay, let's go to the second question. Second question here is just that you observe that the input 0.5 voltage is in the positive terminal of the op amp. So that's a non-inverting amplifier. So I should use the formula for non-inverting amplifier. What is the formula? The output voltage V output is equal to 1 plus RF divided by R1, whatever I have here, 10, times the input voltage was equal to 0.5 voltage. They need to have the output voltage equal to 3 voltage. So just replace the output voltage by 3 voltage. So again, if you divided 3 by 0.5, you got 6. So 6 is equal 1 plus RF over 10. So RF over 10 is equal to 6 minus 1 is equal 5 multiplied. So you get RF is equal 5 times 10 is equal 50 kilo. Oh, it's a direct problem. Easy. It doesn't take, as you see, more than half a minute. If you just solve the homework, you solve the exam of the lecture, it'll be just a piece of cake. Now, let's move to the third question. The third question here, you'll find, it consists of two parts. I will start doing the first part. The first part here, the input is applied to the negative terminal of the op amp, so it's a inverting amplifier. So if you call this V1 and this V output, just to make it easy, call this one V2, just to make it simple. All right, and what's V2? V2, since it's inverting amplifier, be minus this resistance 330 divided by the resistance connected to the input, which is equal 66 times the input voltage was equal 12 millivolt. Just keep it in millivolt, don't convert it, because the answer here in the question in millivolt. So when you do that, so the answer that you're going to get is equal minus 60 millivolt. That's the V2. All right. Now, you look for the second op amp. It's a summing amplifier. So there is two signals. It's V2 and another signal. Oh, that's also V2. So okay, I'm sorry. Just it's better to call this one V3, not to confuse you, because we have already V2. So just call V3 because you have V2 here. So you got V2 and you got V3, and each one is connected to a resistor, and that's the summer. So how you do the summer? The V output will be equal minus, and this resistance divided by this resistance times the input. So it will be 470 divided by 47 kilo ohm times the V3. V3, I got it equal minus 60. So just put minus 60 here, plus This resistance, the feedback resistance, 470, divided by the resistance connected to the other input, which is equal to 47 kilo ohm, time the voltage input at this side, which is equal to 18 millivolts. And just simplify. Obviously, I choose, very nice number. So, 47 divided by 47 would be 10, right? So you have minus, and you have minus 60 times 10 would be minus 600. Plus, this is 10 would be 180. And just subtract and flip the number, the answer, and just you find is equal to 420 millivolt. So the answer here in the box, you should go to 420. As you see again, there is nothing strange in this problem. And actually, this problem, I got it from the homework sheet I gave it to you. I just changed the number. That's all. So if you did the homework, it will be just a piece of cake. Let's move to the question number 4. Again, you'll find you have many op amps. It's better just to find the output of each one. So just let's call them, different names. Let's check. You have, this is V1, V output, all right? So you are free. Call this one V2. Call this V3. And this is obviously a summing op amp. So how you do, find VT. So to find VT, V2, I'm sorry, you look for this op amp. It's amplifier, yes, amplifier. The input connected to the negative or to the positive? No, the input is connected to the positive. So it's non-inverting amplifier. So you are going to use the rule for non-inverting amplifier, which should be equal 1 plus the feedback resistance, which is equal 180 kilo ohm, divided by the other resistance, 20, multiplied by the input voltage, which is equal 2.5 volt. And then calculate the V2, it will be equal 5 volt. Now let's go for V3. V3, obviously the input also to the positive, but the negative feedback with the resistance equal 0. That's what we call it voltage follower. A voltage follower, we explain it in the lecture. That just, does not change the amplitude of the input, neither the signs. So 0.5 volt will be outside here at V3. So V3 will be equal 0.5 volt. So now we have V2 and V3. Start and do the same thing with the summing amplifier. That's the feedback resistance divided by this one, multiplied by V2, divide 20 by 10, multiplied by this. So the output voltage will be equal. And don't forget the minus, all right? Because all the input connect to the negative here. So you have the feedback resistance, which is equal to 20 divided by 20, times the input V2. V2, we got it 5 volt, plus 20 divided by 10, divided by the input V3, which is equal to 0.5 volt. And simplify and get the one, you find is equal minus 6. So what the answer here, it's equal to minus 6. And it's done. Let's go to the last problem. As you see, nothing take more than 1 minute. However, I increase the time for the exam. I make it 25 minutes, 20 plus 5. Okay. Now that's, comparator. So we are comparing this voltage that apply to the positive terminal with the voltage applied to the negative. Well, the voltage applied to the positive, it's given here. It's equal 10 sine omega t. The voltage applied to the negative at this point, and I talk about that in the lecture, that's the voltage divider. So you have to find the voltage at this negative part. The voltage as the negative part is equal to, it's from this point to the ground. So it's across the 25 kilo ohm. And the total voltage applied to the circuit is 10 volts. So it will be equal 10 times this resistance from this point to the ground, which is equal to 25, divided by the sum of the both resistance is a voltage divider, will be 25 plus 25. So the answer will be like 5 volt. So actually I'm comparing 10 sine omega t with the voltage here at which is 5 volt. So if you just sketch, the first half of the sine wave, and there is a problem, there is an example in the slides exactly similar to this one, but just different number, as you said. That's 10 the maximum, and then have it at 5. So if you can get this two angle, call this x, for example, and this is x, then you find one in the middle here, right? All right, how to find this middle angle? You just solve two equation. You equate 10 sine omega t with 5. So I'll say that 10 sine omega t, which is now be equal to angle x, it should be equal 5 volt at this point. So sine x is equal 5 over 10, which is equal half. So what is the angle that its sine is equal half? That will be to 30 degree, right? All right. So now you have the third degree. So you got third degree from the side, and you got third degree from the side. And you know this half wave of sine wave, it starts from 0 and finish at 180 degree. Okay, because one cycle makes 360. So now theta, which is in the middle, will be equal to 180 minus 30 and 30, like minus 2 times 30. Will be 180 minus 60, so the answer will be 120 degrees. So that answer 120. Okay, as you see, it's very simple. And whoever did solve the homework will be piece of cake. All of them from the homework. Okay, good luck and thank you.